This is my Lanair shop heater. It's a 200,000 BTU furnace, and it sits on a 215-gallon fuel tank, which has posts and a platform on top where the furnace sits. It's supplied by compressed air and a regulator set to 60 psi, which supplies a smaller regulator which supplies 15 psi to the burner. The burner has a preheater in it for heating the oil before it's injected in the combustion chamber, and a combustion blower for putting air into it. The has a fuel pressure gauge on it, which shows about 6 psi right now, and there's the air pressure gauge showing about 15 psi. And it has a conventional fan in the back which draws air in through the top and sides and discharges it through louvers in the front. It has a flue pipe on the side of it. It also has a top exhaust that's capped off. You can use either one. The fuel pump draws fuel through a 100 micron filter, which has a vacuum gauge on it to show when the filter is getting clogged up, through the pump, and then pushes it up through a copper tube to the burner. It also has a bypass tube on the side of it which goes back around from the pump and returns to the tank. It's a slow turning motor of a couple of hundred RPM. The fill box on it is a very large, nicely engineered metal box which is just right for dumping 5 gallons of oil in without spilling any. Very rarely do you splatter or spill any oil using this fill box. It has raised expanded metal in the bottom with a 50 mesh screen on top of it to capture trash. As you might be able to see, there's quite a bit of trash in there already, and I have an old filter sitting there draining. The flue pipe runs out the side, and I've run it through an elbow and then out through the wall thimble. This is a steel building, so I had to fabricate reinforcement and spacers for the wall thimble. The 8 bolts underneath the thimble are where the chimney bracket attaches through the wall from the outside. This is a barometric damper, and the barometric damper allows air into the flue pipe. You will get so much draw up through the pipe from the air rising that it will suck the heat right out of the combustion chamber. And this damper is designed to open. It's a counterbalanced vane that opens and allows room air into the flue pipe to slow the draw down. They call for a 0.02 to 0.06 inches of water column draw. This damper has settings on it. This is the horizontal side, as you can see from the H. It's mounted in a horizontal flue pipe, and I have it set on the little curved line that's about the 6 mark. That's a rough setting. If you reach inside the damper, you can actually feel air passing through it. The heater's not running, it's just sitting there, but you can feel the draw going up and out the chimney. You should have a cold draw of at least 0.02 inches of water column. To measure that, we put a small hole, a 1/4 inch hole in the pipe, and then we use a device, in this case a Baccarat draft right meter. It is level dependent. If you tilt it, the needle reads off to the side, and to the right is negative inches of water column, and to the left is positive. So I would be looking for the needle to read anywhere from right there at 2, which is 2/100ths, over to 6, which is 6/100ths of an inch when it's running. To zero it, it has a hole in the back side of it, a finger hole, and it has this tube on it which is screwed into it, to insert through the hole in the pipe. The draft is measured cold by putting your finger over the draft hole in the back of it, inserting it through the hole in the pipe, and leveling it till it reads 0. While holding it steady like that, you remove your finger off of it, and it should show a draft. In this case, I'm not showing 0.2. I was earlier. I'm not sure here. Let's try this again. Finger over the hole, tube into the pipe, and we get some movement. We're not getting quite 0.2 out of it. I was getting a very distinct 0.2 earlier. Let's try this one more time. It's kind of an art to this. There we go. I think if you insert the tube too far, possibly it does that. So I'm reading 0.2 right now. I've been preheating the heater, and we're about ready to fire it off. Power's on. We have compressed air. The preheater's on, as evidenced by the glowing red switch up there on the bottom of the burner. And all we have to do is take the thermostat here, and we move it out of the off position, and then we push it up above the temperature in the room. It's rather warm today. It's about almost 60 in here now. The combustion blower starts up. You can see the louvers on the combustion blower, which have an adjustable vane on them. And it pushes air into the combustion chamber, and it'll light off here in a moment. Until the combustion blower, yes, it's lit. I can hear the rumbling, and the pipe's starting to warm up. And once it gets going, we'll allow it to burn for a little bit, at least until the blower starts up on it. It has a temperature switch on the blower that turns the blower on when the combustion chamber gets up above 125 degrees. So we'll wait, and in a moment here it will start up. The blower's just started up. You can hear the roar of it now. And the air coming out of it is slightly warm. It will continue to heat up as the combustion chamber heats up. We'll give it a couple of minutes to come up to temperature. The fire is set by adjusting this louver here to control the amount of air going in the combustion chamber, and by adjusting the air pressure, which is a little bit low right now. So we'll adjust it up. It should be around 15 pounds. If you want to see the fire, this is looking through the backside of the combustion chamber, or through the backside of the burner. You can see the louvers, the burner, and the fire roaring away. Or you can look through the viewing port to see the fire inside. The fire should not reach the target wall on the far end, and it should be a nice, clean, yellowish orange flame like that. The dark flame is too hot. If it has sparkles in it, it's not set right either. On top of the burner is the power for the ignition and the hookup for the thermostat. The entire burner assembly is bolted in and pivots on the pivot pin and will swing out for cleaning after you disconnect a couple of lines. If you watch, the damper's sitting there rattling or fluttering. which is a pretty good indication that we've got a good draft, so much draft that the damper is having to function. And we'll put our finger over the hole. We'll insert the tube slightly. We'll level it. And we remove our finger, and we got over 2 and close to 4 at any given time. Let's try this again. Take that, we insert it in there slightly, we level it for 0, and then we take our finger off of it, it jumps to 4 and settles back to about 3 or so. So at this point, we probably have a pretty good draft in it. It's acceptable. Possibly could stand to be a little more, and I may eventually adjust the counterweight on the damper. But at the moment, it works fine.